Okay, so I thought it would be fun to take a look at BERT and the Hugging Face libraries and just look at three examples. I'll only show two, but so we've looked at sentence classification. So I'll zip through this one and then I'll show you another one. So BERT has a couple of use cases. One of them is question answering. The other one is like sentence classification. Another one is named entity recognition. So I'll cover the first two and I'll talk very briefly about named entity recognition. But the focus really is on just showing how easy it is to use the transformer libraries. And most of this code I've been able to cobble through from different sources. So it's limited input from myself, but it was just interesting to put it together. So BERT has 12 layers. And what's quite interesting is that if you're actually after sentence classification, then you're actually after that first bit that's available right at the on that final layer. And so that's what you're looking for. And that's where the information will be available with regards to sentence classification. So it's actually quite simple. You can start off with, just pulling the transformers library down from Hugging Face. And I'm using the Cola data set here. And so this one is whether the sentence is grammatically correct or not. So you can just pull that down. And so if you take a look at some of the sentences, let me see if I've got one here. Apologies. So we've got this one here, right? Yeah, so I think it's, so apologies, it's been a few days since I looked at this. I think it's 1 is if the sentence is grammatically correct and 0 if it isn't. So we can probably take a look at some of the, so do I still have is this still just live? I'm guessing, so I'm just gonna try this. Oops, sorry. Is my thing still, okay, it's still working. So just hang on a sec, let's just have a look at something where, yeah, so 0 definitely means it's not grammatically correct, right? So John ate dinner, but I don't know who. John is tall on several occasions and so on like that. So 1 means that it's grammatically correct. 0 means that it isn't, right? And so we can pull them all. So we pull them all into. So these are all in NumPy arrays, right? And then and this is what's quite nice about this the Hugging Face library. So you apologies. So you go from BERT tokenizer, pre-trained, and then you've just got a whole load of these different ones, so BERT based uncased and so on. And we've looked at this before, so I'm not going to belabor the point. But what's quite nice is, so you can take a look at the sentence, what it actually looks like when you tokenize it. So BERT splits it up in that way, and then you can look at the token IDs in this way. And then one of the first things you probably want to do is to figure out the length. Although BERT and please interrupt me if I say something that you want to you disagree with, because that would be helpful for everyone. So one of the first things you want to do is figure out which one is what's the maximum length of sentences in here. That I think that's the main reason you do that is if you just went with the 512, it would just take a lot longer than if you just stuck with you just tried to figure out what the longest sentence was. So here it was actually 47, but I just stuck with 64. If I had left it at 512, which is the case for, which is the number that BERT supports, I think the training would be really long. It's something I need to look into. And then there's this really handy class called Encode Plus, which does all of the stuff that you need. Things like putting the CLS at the start of your sentence, the separators, at the end, and so on. And it also gives you the padding and the attention mask. So the attention mask is around whether it's a padding, if the token is a padding one or not, and then you're just returning PyTorch sensors or TensorFlow. And so in this case, it's just PyTorch. And then you get this dictionary. So you have input IDs, token types, and the attention mask. And you can just work your way through them, right? So this is now encoding your sentence into these tokens, and you can see that the zeros correspond to padding. And then you can just create a, what's quite nice and which was news to me was you can, I thought, typically you'd always have to go down the scikit-learn route. Actually, a question out for everyone. So, normally if I was splitting training and validation data and so on, I would have gone down the scikit-learn route, right? But it was quite nice to know that you can actually do this in PyTorch. So I don't know whether you guys have experimented with that and found the PyTorch as good. Clearly, it's not going to be as seasoned as the other one, yeah. Sorry, so the PyTorch won't be as seasoned as the scikit-learn one, but it was quite interesting to be able to use this, and so I tried this one out. So creating your train, data loader, and validation one, and then just training. Right, and so this is quite nice. So if you go to the, so this is the Hugging Face Transformers link. They've got some really useful information around all of the different BERT pre-trained models that they make available, right? So there's the uncased and cased and different languages and so on, and when you should try different ones. And so because this is just a regular sentence classifier, I think you can get away with a BERT-based uncase, which seems to be the, I think it's the fastest running one. The other ones would probably take longer. So the BERT large, uncased, and so on. But it'll be good to experiment with them and try and figure out the differences. Has anyone experimented with the different ones and found I know we've covered some of this stuff in previous things, so I know this is not new, but has anyone experimented with any of the other ones and found, like, anyone tried any of the multilingual stuff in particular?
I've tried out the DistilBERT one. It's pretty fast.
Yeah, that's the really scaled down one, right? So that's the one where it tries to capture or reduce the number of weights, but in a much smaller model. Yeah, and surprisingly, I didn't find the base uncased or so even though it's pretty large, right, 110 million parameters, I didn't find that was that slow. So just just a couple of minutes. So this is your fine-tuned model. So I've used BERT based uncased in this case. Two labels because we're looking at grammatically correct or incorrect sentences, and then so based on the BERT paper, these are the recommendations. So let me BERT paper. Oops, not BERT. I think it's this one. So if you go to the appendix A3, oopsies, have I gone too far? Apologies for the scrolling. I will try and find it. Oh, have I got the wrong paper? A3. I think I've got, okay. I'll come back to that. I'll post a link to that. So there's an appendix A3 available with one of the associated papers, and these are the batch sizes and the learning rates and the number of epochs that the authors tried, and they seem to get good results. So so I've gone with 4. So again, some useful documentation on the Hugging Face side of things. So it gives you some basic code that you can use to help you put together a training set. and again using AdamW as the optimizer. So this was some useful framework to help with training, putting together the stuff that you need for training. So you'll see that you have your batches, you calculate your loss, you do your gradient descent, you clip your you do gradient clipping to ensure that you don't have any the exploding gradients, and then you have your scheduler and stepping through your scheduler and the optimizer, and that's basically what you have here, right? In this code, where you just work through the different batches. So I'm just going to go back to yeah. So I've worked through the different batches. I make sure that they're on the I move them onto the GPU for the training, right? And then I'm doing exactly the same thing that as suggested in that code. So running it through the model, you get your back propagation, clipping, optimizer. So all of that is from that bit of code that I showed you above. And so you work your way through the batch and the so the training batch and the validation batch, and you get your time for each of those, and you can have a look at the results. So because the sentence classification it's a tricky one in terms of how do you know if you've done reasonably well. So as part of so you've done the training in that previous section, you then go ahead with testing, right? So they've as part of the Ecolo dataset, they give you a test dataset that you can work with. So doing exactly the same thing in terms of data preparation that you did at the validation side of things, right? You have the test data, and again, you use your BERT tokenizer, and you use the Encode Plus that includes the your tokens, the CLS and separators and so on. And you can do then you determine how well it's done on this test set. And then the only way to really evaluate this is there's something known as Matthew's correlation coefficient, which we've mentioned before in previous meetings. And so the way to determine whether your model is done reasonably well, well, this is because this is a fairly well-known data set. You can go down to the glue benchmark. And so you can see that the results that I got when I ran this, I've got like quite a few different results, 0.52 to 0.6 something. And you can see that the Kohler data set, it's a little bit higher. So it seems to be that a reasonable amount is probably around 70s. So I probably want to maybe train a little longer or try and figure out what's wrong, but it's not so the data set that I've got without doing much work at all. And this is again taking a pre-trained model, so I'm not doing I haven't done a massive amount on it, but it's still within within the top whatever that you've got. Actually, this is not sorted, so it doesn't tell me a lot, but at least I can see that it's it's not way out there. And I haven't done a massive amount of work on this, but it's nice to see that. So this is, and again, the purpose of this was to just try and just have a quick look at some of the different use cases for BERT. So this is sentence classification. Any questions or thoughts on this, or anyone else tried the Hugging Face library and have any comments on that?
Hi, John. I'm sorry, I haven't tried this before, but I missed your model. Can I see the model? Is the model something that you've created, or is it just something that comes straight out of Hugging Face?
I think that's this is what's quite nice about this. I didn't do anything, so the model actually comes from Hugging Face, and that's your model here.
So you don't have to add any layers or anything on top to make it into a classifier or anything?
No, because this use case is sentence classification, right? I didn't have to do. I specified further down that this is for let me just find it. I specify here that I'm actually doing sentence classification. Now, here you go, BERT for sequence classification, and so that's my model. So it's really. Yeah, it's really quite simple. They've made things really quite simple. So yeah, so I encourage you to try it out, and I can make this notebook available. So
that'd be great.
Yeah, so I think that's that's why this, I think this definitely makes things significantly easier when you're looking at NLP stuff, when someone's actually done most of the work for you and you just have to use the model. So this was a nice, so sentence classification, and this is kind of review because we've seen most of this before. And then another use case that I looked at was not this one. So this, yeah, okay, here we go. So this one is question answering, right? And so again, in the similar vein to what we did before, this time I'm actually not going to use any other data set. I'm just going to use the train model, and let's just try and figure out how. So again, you got your BERT model, right? It's again, I think it's 12 layers. I can't remember. I think one of them I used 24 layers, but this is your BERT model. But this time, so this is not a classification task. So this is not where you want to get your answer, because what we do with the question answering model is you actually have a start and an end delimiter. And so basically there's a line of text and then you have a response. And what BERT does is gives you the answer in terms of that start and end span, which will have the answer to your question. So I'll give you, there's another diagram that I can show you on that. So again, very similar, get the transformers, get torch. But this time round, we're using so this is fine-tuned on the squad benchmark, which does exactly this. So the squad benchmark, hang on, so let me just see if I can get that squad. Is it this? Yeah, here you go. So this is what it's been trained on, but this is version 2. I think this one, I think the BERT model is available for version 1, where I think the one of the differences is there's not, so version 2 has the option that the response text. So you've got the question and then you got this response text, and your answer is supposed to be within the response text. But in version 2, the response text might not have the answer to the question, which I think is a bit mean. But so for example, if you just were to take the example of oxygen, right? So this is your text, right? And then you might have the question of what's the atomic number of the periodic table for oxygen, and you know that the answer is 8, and you can see the responses. So you have the ground truth answers, and you can and so this is what this has been trained on. So you have these questions, and it's getting the answer from this text. So so with that in mind, right? Oh yeah, so this is the one where you're actually using the 24 layers of the BERT model. So it's not 12 anymore. And again, what's nice is it's so you're doing a BERT tokenizer, but you're just getting the fine-tuned on the squad data set, right? And so you're just using that thing. And again, your model is just BERT for question answering, right? From pre-trained from that model. So again, things are pretty simple. So I made up, I didn't make this up, apologies. What I did was I looked for English, like really short English comprehension texts. So, and this is what I found. So I found something on dolphins. And so dolphins are regarded as the friendliest creatures in the sea, and stories of them helping drowning sailors have been common since Roman times. The more we learn about dolphins, the more we realize that their society is more complex than people previously imagined, and so on, right? And then what I did was I then asked a question which I thought didn't really answer or didn't use the same words that they have in the text. So I said, which people have dolphins assisted? And the question and what the response has is, dolphins are regarded as the friendliest creatures in the sea, helping drowning sailors. So I didn't use the word helping. I used the word assisted instead. And I didn't say, humans or sailors. I just said people. And so what we might want to do is try and see how well this does. So again, you encode this in BERT. And so the way you do this with the this use case for BERT is you have the question, then you have the reference, right? And so you need to specify which is the question and which is the reference, which is you do by this embedding. So basically what you do is you have a CLS at the start of your text, and the separator that tells you the difference between what is your, so this bit is your question. So the CLS all the way to the separator, and the separator onwards is where your reference text is, and your answer is going to be somewhere there, right? And so that's what that dolphin text that I gave you looks like. So you can you then have this separator index that allows you to split them up and you can then have the segment IDs, which basically allows you to say, so zeros means that they're all part of the question, and 1 means that that's the reference text. And what you want to get out of this is, what is the start and end delimiters, which is the answer, right? And so this time around, actually, you don't need the Encode Plus. I need to look into this because I thought you could always use that because it would be quite helpful because it was a really nice tool that added the CLS and so on in place. But this time around, oh yeah, and I because I'm just checking to see how good the model is, and I'm using a pre-trained model, so there's no, I'm not fine tuning any other data set, so I don't need to do I don't need to look at any of the training stuff that I did in the previous example. So I can go straight to testing because I've provided the question, which is the one around which people does the dolphin help, and the response was in that text. I can go straight to evaluate it. And the way you evaluate it, as I said, was, you have this start token and the end token, or this index, which tells you how well it's doing. So again, so it's not 12 layers, you've actually got 24 layers in the example that I've got. And so you pick the one that has the highest value that's the start of your answer. And you pick the one that's the end, the highest value for the end. So again, I think this is just softmax at the softmax layer at the end of your model. And so you got these start and end scores. And so basically the highest one is going to be the one that it would suggest is the start of that answer. The highest for the end is going to be the end of the answer. And so doing that, right, so you take the highest values for start and the highest values for end, and you see the answer is drowning sailors. And so the question was, apologies for scrolling. Which people have dolphins assisted? And it's drowning sailors. So I thought that was pretty remarkable. So I mean, anyone else can make up any other question if you think that's relevant for you, and you can see how it does. But I think what was quite special about this is I tried not to use the words that were here, and this is not a very complicated text. I think I got it from like so someone who's in like it's English comprehension for like class 4 or 5, so year 4 or 5. I mean, if you look at some of this text, this is a lot more involved and complicated. So perhaps I shouldn't be surprised because I've given it a lot easier text. But that was quite interesting to see how that performed. And yeah, and so you're getting these results. And then in fact, if you go ahead and plot the tokens, right? So you can get the answer start on and answer end. You can go ahead and see that. So oops, that's unfortunate. Oh, yeah, hang on, I just scroll back up here. So you can see that my start word score is the highest for this, and that will actually correspond to drowning, right? And if you look at the end score, so that'll correspond to where that ends. And this one is actually sailor. So drowning sailors, and that's what determines that answer that's returned to you. So that was this was the second use case with BERT. So that's question answering. And again, you're just getting the results from that final layer using softmax. I didn't have a chance to, or I can show you a little bit about named entity recognition, but I haven't finished this. Finish this yet. I can make this available once I've got this done. So again, the similar sort of thing, except this time. So remember, for the sentence classification, we really cared about what was stored in this value, because all of the results in terms of the classification, the answers or the wealth of answers was actually stored here with the Q&A, the question and answers, that was telling you the start and end span, and that was again giving you a softmax over here. With named entity recognition, this is where you have these different values. So for people, and this can vary based on different data sets. And this allows, so O means, I've just got a little bit here that I can show you, but I can give you the rest later. So I think this was one on some a restaurant data set, but O means the word is not part of the entity. B means that it's that it is a single word entity that you care about, and I means that it's following on from something else. So So in this data set, I think this was around restaurant recommendations or reviews. So 0 means it's got nothing to do with, it's not an entity you care about, but B is you do care about 4, but it's part of the entire entity, as in, B is the start and I is the rating. So 4 star would be considered one entity over there. Restaurant is in this case not considered one of the entities, but you define that, you define which are your entities and you label your data set in that way. And so in this case, these were the entities that had been selected. So it was restaurant name as opposed to restaurant. And so this is what was used for this data set. But I would imagine that if I complete this, it would be very similar in that, so again, I'm able to use BERT. I need to figure out, and so I'd go back to this, and this is what's quite interesting. If I go back to here, I think it's here, right? There's some notes on, here we go. So there are some notes on named, so here you go. So in the other instances, I've used the BERT uncased model, but it looks like, so typically the uncased model is better. So I'm just going to highlight the bit I'm looking at here. So typically the uncased model is better unless you know the case information is important. So it looks like for a named entity recognition type problem, I'd probably want to go for the cased model, while as uncased means that they basically just lowercased all of the word piece tokens. And so that's, and that, I think that's a smaller model, and that gives you good results, but presumably I would care about the case when I'm using something like named entity recognition, because that will correspond to some of the entities that I actually have, that I might have defined in my case. And so that's why it makes sense to actually care about the case of the words. And so, so I would imagine that if I was to finish this, sorry, not this one, go back to this one, I'd be able to then have a text that would determine, is this a B, an I, or an O, and that's and so that achieves the named entity recognition component. So yeah, those are the 3 use cases that I've managed to cover in 20 minutes. But it was I'd encourage you to take a look at Hugging Face if you haven't. It was they make things quite easy. Any questions about any of those 3 use cases?
So in NER, is it like each token is classified as whether it's O or BPER or and PER? Is it like that?
Yeah.
Each token is classified
So
into
everything
one
is
of...
classified. So from what I've looked at this so far, everything is classified as O, B, or I. That's right. Yeah.
What's I? I is
I means that it's part of that entity, but it's not the
okay.
start, right? So you might have something like 4 star. So star is clearly part of that entity, but it's not the start of it, and that's why you have the I. Yeah. But yeah, I mean, these are just three use cases for BERT. So it was quite useful to take a look at. You've done a fair bit of work on this kind of stuff, haven't you, Gautam?
Yeah, on simple classification, yes, not on NER.
Right. So when you were doing the text classification, what kind of stuff were you doing?
So mine is a bit different from what you did. I took the BERT model and then I made a PyTorch model on top of that. And then I just had my own tiny neural net attached to the end of the CLS token. So that's what Hugging Face does for you when they give you BERT for sequence model classification.
Yeah. Okay.
So
what you could have done was presumably another option that you have to check how good your other model would be to just take a pre-trained model from Hugging Face and do that classification task here.
I think you could, we can fine tune the sequence model that BERT gives as well, right? The BERT for sequence classification. Sorry.
Yeah, absolutely. Right. That's exactly what I did here. Yeah. So
Yeah,
this
it would be
would be
good to
the,
compare what what transformers gives you automatically. Yeah.
yeah. Yeah. Anyone else used any of the Hugging Face models? So outside of classification, Gautam, what else have you, or has that been your main use case?
That's the only one I've really explored, to be honest.
Okay.
Not much. I've used the NER,
yeah.
the one that you don't have to train, right? They automatically give you organization, location,
Yeah.
all of that stuff. I've used that for my company once, but that was just out of the box. You don't have to do anything. It gives you really good predictions of organization, location, and all of that. I think better than Spacey and all of that. Yeah.
Right. Okay. Yeah. I mean, I guess if you had to do that for like a specific data set, that would be a pain in the neck, because that would be quite, well, having to come up with all of the labeling. So that wouldn't be fun.
Yep.
Yeah.
Sorry, John, with the question answering one, are you just using BERT to predict a start word and an end word in your sample answer? It's not sort of
in the review. So there's the answer. So what BERT has to do, and when it's trained on Squad, right, is to tell you the start and the end of where the answer is within that text.
All right. So like there, your answer was drowning sailors. But it's not actually sort of forming proper sentences as the answer. It's just pulling out a sequence of words between the start and the end. Right.
Yeah. This is not. I think this is not an Alexa or yeah.
So in the NER and question answering ones, the CLS token will never be used, right?
You use the CLS at the start, right? So the CLS is always used because that's just how it's encoded.
I mean, in the final task, the question answering task, you don't actually use it, right? Because it can never be the start of your answer.
Oh, sorry. You mean this one right at the top? This one?
Yep.
Yeah. No, because that's not your. This is why I was quite interested to look at it, because this is not a classification problem. This is where you want these two values, the start and end span. So I think so. So I think what would a next step would probably be, okay, so you create your own BERT, and then you've got to go and create and figure out how you're gonna. So I think what they've done here, though, in this case, is just done a softmax at the end, haven't they? Where they've figured out that's what we saw at the end, right? So they've just done a softmax right at the end of this, which allows you to determine what's the start and end sequence, which gives you those answers. So so I guess it's just a regular BERT with that softmax layer at the end.
It's still amazing that it works. The drowning sailors one was pretty good.
I know. I mean, what we could do is you could try and come up with another question.
What if you ask which people have dolphins hurt?
All right. Okay, but it will come. So it will have dolphins hurt, right? Did you say hurt? Okay.
Yes, I did. Yes.
So I'm guessing it will come up with the wrong answer, right? Because that answer is not in the text, but because it's got to come up with something. Oops, what's happening here? Oh, sorry, I don't need the training thing, so I can jump straight to, hang on a sec. Let me just do this again. Right, so we've got the text there, we've encoded it, tokenized it, and now I jump straight, because we're just doing a evaluate, right? So I'm going to jump straight to evaluate to get the test score. Oops, what's happened here? Is there something I don't need to? Okay, hang on. Let me just run this again. So yeah, okay, let's take a look. Right, so which people have dolphins hurt? So we tokenize that. That's our tokens. And this is our segments, right? And then we jump straight to evaluating it. Right, so yeah, I mean, so I expected it to give an answer, and that's only because you got a softmax at the end, so it has to give one. And I guess this is the difference between squad 1 and 2, where I said 2 can actually mean that the answer is not in the text. But what's quite interesting is it's still the emotion of hurt or something, right, has still turned out to be sailors. It could have been, you know, other dolphins or I don't know, right? But it's got to, but I think because this has been trained on well, because this is softmax at the end, it's got to come up with an answer, because we're not having a, you know, we're not saying putting a threshold or something. But if we would
become more unsure, you know, you can look at the score.
Oh, we can look at the score. Oh, you know what? Why don't we look at the pictorial representation, and that way we can see whether it was less certain. Yeah, so I don't know. It has a start. So those are the two things where things is likely to start, and it looks like that's the most likely. So it's in one sense, I guess you could say. I don't know how you'd interpret that, because yeah, I'm not sure. Because I think in the previous one, right, one of them was clearly higher than the others, and so perhaps that's that's an indicator. But what if you were to ask another question that was actually, you know, from the text?
Did you see anywhere that they use softmax for this?
I'm guessing it's softmax because you've got you've got this thing at the end, right? You're getting these maximum values at the end, and it's picking the maximum one. So that's my guess. Right, I can't imagine what else it could be. Right, because
it could be just argmax, like just maximum.
Yeah, sure. But I mean, it would have had to have passed through a softmax first, though, right? Because you want to compare all of your final tokens to see which one's the largest, and then you're saying, so yes, absolutely argmax, but argmax after you've done a softmax, right? Because so you are doing an argmax at the end, but that's because you've gone and compared all of them, and then you've kind of normalized them, so to speak, to figure out which one's the highest.
Actually, softmax is like order invariant, so you have the same order of like, yeah, softmax does not affect order.
Yeah, softmax is basically like for the purpose of loss calculation. Softmax is for the purpose of loss calculation, which PyTorch probably does automatically. It's the same as the result would be the same as argmax.
Yeah, so it's that e to the x over the sum of e to the x, right? So that gives you a score. So basically, it's a means of scoring everything, and then argmax just tells you which is the highest.
Yeah.
But if we were to put another question to it, or just like a totally different question, short English comprehension. Oh yeah, so this is the one I actually got this from. I got this from here. Right, so never clean that. Okay, so this is a, like, so you can say, okay, I'm going to ask a question. Difficult. How many people survived, right? Because I'm going to ask the question, how many people survived? What's wrong? Sorry.
John, my suggestion would be if you can ask how many died,
sure.
because it is the souls and it doesn't use die exactly.
Yep, sure. How many people died?
Yeah.
Yeah. Right, I'll overwrite the answer text anyway, so that's not a problem. Right. And then we go straight to the evaluation. Okay, here we go. So we're gonna get the start and end scores. Oh, 139 died. I don't know. Let's have a look. Only 113 survived. Oh, so I got it wrong. Good question.
I mean, like you said, it just it looks at the softmax score, and
yeah,
this was the one that had maximum, I guess.
Yeah.
There's no option, but it has to give some answer, right? That's why it gave.
Yeah, sure. But I thought, well, see, the thing is, it says, right, it went down to most of those on board had no chance to save themselves, right? I thought it might be smart enough to come up with that. And
no, the reason I said it was it says the final death toll, so it has to know that.
Add that sentence.
I didn't add. I think I just took the up till here. I think I think I only took.
Oh, then it wouldn't have gotten it. You need the whole paragraph.
Okay, let's be okay. So apologies, I didn't get your. I didn't.
Yeah, I don't think you copied the whole thing. I would have had to have gone and looked on Wikipedia for the answer.
Yeah. Okay. So apologies. I was just trying to keep something short. So okay. So all the way to elderly, right? Okay. So let's try that again. Right. So while most of the dead were okay. So there you go. And if you go down to, oops. Okay. There you go. Oh, that's odd. 912. So where did it get that from? The final death toll amounted to 912. Oh yeah. So what was the question again? How many people died? Did we say that?
That's right.
Oh, that's pretty good. Yeah. So that's pretty good. Apologies. Let's go back to yeah, that's not bad. Yeah, so I mean, it's yeah. there's a reason why people are so excited about BERT. But so I guess the other question I have is like, this is, I think what horrifies me is this is like 2 years old, right? So I'm sure we've come ages in those 2 years. And do we know what's kind of next? Because I have no idea what's post BERT. What's giving you better results than BERT. I guess I could go to the squad. Sorry, not the squad one. I could go to this other glue benchmark, and I'd get a pretty good idea of which one's better here, at least for some of the tasks. Like so, like for the text classification. Yeah, so like some of these are way better, but or I guess just variants of BERT, so like struct BERT, Macal BERT, but it seems to be that BERT is the BERT-based models seems to be the thing. I mean, I have no idea what Roberta is or any of the other ones. Has anyone else used something that's better than BERT?
Well, I played with generative models like T5 here. So it's like abstract question answering. It doesn't extract a span from a text, but it actually generates an answer when you ask a question.
So sorry, say that again. So what you're saying is, if you were to give a question and a text, it would not give you a span as a response, but it would generate an answer that is a response.
Yeah, right.
Okay.
And it is capable of doing multiple tasks, like question answering, summarization, MNLI, this, and like deciding if one sentence contradicts another or not. And that's like one model that is capable of doing that. And another model which works with abstractive tasks is BART, which is like Facebook, by Facebook. But I don't know how do they I think they in some tasks they are better than BERT, and in some tasks they are worse. So.
Okay. Yeah. Yeah, and I think these are the if I go back to the let me just see if I can find the right one. These are the main use cases for BERT. Do I have BERTology? Is it this one? No, this is just telling you about BERT. Yeah, I think those are the main use cases for BERT. So sequence classification, token classification, question answering. Oh, I haven't looked at multiple choice. Maybe I should take a look at that. I thought those were just the three that was available, but clearly there are more. So. Okay, well that was just a quick flavor of BERT, but we can all go back to following the US elections and be horrified by how close it is.
I think Biden has been elected now. They
just has
announced.
He?
Yeah.
All right. Okay.
Yeah. Well, thanks a lot, John. That was really useful to look at that.
Yeah. No, not a problem. That's interesting. What have you got planned for next week?
Well, we're supposed to go into the next lecture, but it's probably nice to keep exploring BERT. I mean, that's what I would like to do, is just to keep exploring these BERT architectures and get a better understanding of them. I wonder what other people feel about that.
How many lectures are there left on the
Let's see.
course?
Let me look. I think there's just 3 or 4, maybe 4. Let's see. Okay. Here we go. Okay. So what we have is number 16, co-reference resolution. And as far as we had before, Gautam was going to do that. I'm not sure, Gautam, if you're still on board with that.
Yep.
Okay. And then there's multitask learning, number 17. And then there's constituency parsing and tree RNNs. And then there's bias in AI. Dion was going to do that. I'm not sure if she's still on board with that. We'll see. And then there's future of NLP and deep learning. So we have, as it stands, 5 more lectures to cover. So I don't know. I feel like continuing to explore BERT. I don't know how other people feel about that. Like finding good blogs and papers and code to read and look at.
In some ways, I'd like to get the lectures finished as well to sort of complete the course.
Okay, that sounds reasonable. How many other people are on board with that? Because we could easily just move on and start, do 16 next week and then move through the rest of them, and then afterwards we could decide to, maybe after we finish these, we could decide to start a paper reading group on this subject and move from there.
In fact, the lecture 17, which practitioner that Richard Social guy talks, is fairly interesting, because at least my understanding that NLP is again trying to move to doing multiple tasks with a model, which I think somebody else referred to as well. And Social goes into that particular aspect through Salesforce research and what they are doing, and trying to get the best benchmarks, if you will, on a multitude of tasks with a single model rather than multiple models or model per task. So that's a very interesting lecture.
Yeah, and we've already seen that the BERT model itself is trained on multiple tasks. In this case, multiple is 2. So we've seen that works pretty well. Remember, because BERT does the sentence matching task and also the prediction task. Okay, well, I'm fine with that. So in that case, then let's just do that. Do co-reference resolution next week and march through the rest of the lectures.
Yeah, like if everybody's happy with that, I'd be happy to go like that and finish the course and then come back and sort of drill down into a bit more BERT and any other sort of more advanced papers that have come out recently.
Yeah, I mean, I would really like to have some kind of a papers with code reading group where we pick some paper that has code, for some state-of-the-art task, or maybe pick some task that we're interested in and then start reading some of the associated papers and get up to an understanding of the state-of-the-art in that task. This is kind of like what Srinivas did in the previous Kaggle competition, the Severstal Steel, where he sort of marched through a number of modern papers and got to a near state-of-the-art understanding of how you do these defect classification problems.
Yeah, we'll be going through that for the current one once we, in NLP as well, the question comparison stuff, once everybody spends a few more weeks banging our heads against trying to match even 3-year-old scores. Mm-hmm. That gives us all the motivation we need to understand what the papers are really talking about.
Yeah. Okay, so let's do that then. Let's then convene next week, and as Gautam said, the election has been called. It hasn't been completely resolved, but it's been called. So that gives you something to do in the next hour before we wait for the next class. You can catch up on the news. All right then. See